Hello, good afternoon, good morning everybody. I hope you had a wonderful weekend. If we're on schedule, this should be a Monday, September 25th, and we should be on lesson 3-5. Okay, our topic for the day, solving equations by using models. Solving equations by using models. Page 117. What are our objectives? Okay, students will learn to solve addition and subtraction equations by using models. We're going to learn to solve addition and subtraction equations by using models. Okay, look at example number 1 at the top of page 17. Example number 1. Okay, first I'm going to solve it algebraically. Then I'm going to solve it using, let's back up a little bit, class. The first thing I would like to introduce you to, first of all, let's make sure that everyone get a package of algebra tiles. Everyone. Now, if there's not enough for everyone to have one, some students will have to share. So everyone get a package of algebra tiles. Okay. Take your algebra tiles out, and let's identify what algebra tiles are and what their values are. Okay, first of all, I want to introduce you to this represents a positive 1. Now, why is it positive 1? Because this is a square, all four sides is 1. So this represents 1, okay? Okay, next we have, we'll call this x. This is x because, like the square here, this is a 1 by 1. But if you put this close side by side, this is a 1 by unknown. So we call this x because we do not know how long this is. So this is a 1 by don't know. So we call this x. We'll call this positive x. We'll call this positive 1. And this x and this is the same length. So this is 1 by x, which is 1x. This is x by x, and if you know geometry, length times width, x times x gives you how much? You're right. This is x squared. So this is a perfect square. So we don't know the length of these four sides, so we call this x squared. So we have a positive, let's go through this. We have a positive 1. This yellow is a positive 1, 1 by 1. This is a positive x, this green. This is a 1 by x. And this is a positive x squared. Okay, now, positive 1, positive 1x, positive x squared. Okay, 1 by 1. 1 by x, 1x, and x by x is x squared. Okay. Next, let's introduce, so let's write up here. These up here are called the positive. These are the positive, what? Algebra tiles. Don't forget that. The positive algebra tiles. Make sure you identify those. Same thing in your package. Next, let's identify the negative algebra tiles. Okay?
For them, they just flip it over.
Thank you. Okay, now, Melissa's helping me out a lot with this. Okay, here we go. Okay, look at yours. You notice mine are see-through, but yours have different colors on both sides. Okay? So I want to make you understand that. So one side you have a red square, on the other side have a blue square. So yours have different colors on both sides. So that means, since I said blue is positive x squared, this is your positive x squared. Your red, now if you flip it over, that is a negative x squared. Okay. Now let's move on. Let's identify the. So likewise on yours, positive 1, 1 by 1, positive, which is green, positive 1 by x, x squared, and a positive x, and positive x squared. Okay, I'm talking too fast here. So like yours, this is your positive x squared. This is your negative x squared. Okay, let's put that down. And likewise, this is your positive 1x. This is your negative 1x, which is red. Okay? And likewise, if you look at your 1 by 1s, okay? This is your positive x, which is yellow. Positive 1, I'm sorry. This is your positive 1, just like my positive 1. And this is your negative 1, which is red. Okay. So now, you have everything that I have is mine. Now, only difference, mine do not have different colors on both sides because mine is see-through. Now, let's go over the next house, okay? Okay, I have a red 1 by 1. This is my negative 1. This is my positive 1. Okay, now, this is my negative x. This is my positive x. And this is my negative x squared. So notice, all my reds are negative.
Just like theirs.
Okay?
Just like theirs.
Just like yours. Everything just like yours, okay? Except mine is 3 see-throughs, yours are not, so yours has a different colors on both sides. Alright. So now, let's play with these a little bit now, alright? Let's take these off before we get to our first example. Okay. This is positive 1, 1 by 1. This is a negative 1, 1 by 1. What happens when you add a 1 plus a negative 1? What happens? Well, since they are opposites, don't they cancel out each other? Of course. So we have 1 plus a negative 1, that gives us 0. Now let's try something else. Let's try. Let's continue here. All right, I had to do just a few minor adjustments here. I want to make sure that I'm saying everything clear here. Now let's do some minor calculations with the algebra tiles. Okay, we have, what is red here? This is negative 1. Okay. And here's a positive 1. Okay, now let's put down 2 positive 1s. What would happen if I have, how can I write these as integers? We have 2 positive tiles, 2 reds, and 1 red negative. So how do I write these as numbers? That's a positive 2 plus a negative 1. Positive 2 plus a negative 1. How much is that? That gives a positive 1. Okay? Let's do another one. Now, let's do, and let's erase this. Let's see. Yes, let's erase this. Thank you, Melissa. Let's do another calculation. Okay, now suppose we have 4 positive 1s and 2 negative 1s. Let's write that out, okay? Isn't that positive 4 plus a negative 2? And how much is that? That is a negative 2, because what happened? 2 of these are opposites, so the 2 negatives cancels out the 2 positives, or the 2 positives cancel out a negative. What's happening when you take these out? That leaves, should be positive 2, right? That leaves a positive 2. Very good. Let's do one more, please, okay? Let's do one more. Let's do one more. Erase all this. Okay, is everybody following me now? Okay. This time, let's put up 9. Oh, let's put up 9 here. 9 positive 1s. 1, 2, that is 6. 3 more. Excuse me.
Bless you.
Okay. Okay. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We have 9 here. Let's put them all neatly together. 8 and 1 more is 9. Now let's put down 4 red ones. Now, how can I write these out? How do I represent these as integers? Okay, we have 9, a positive 9, plus what? A negative 4. How much is a positive 9 plus a negative 4, or positive 9 charges plus a negative 4 charges, or 4 hot Q's and 4 whatever you want to see, okay? How much is that? That gives us a positive 5. Now, how does that work? Each negative and a positive cancel out each other. Let's do that, please, okay? These two and cancel out each other. These two cancel out each other. These two cancel out each other. These two cancel out each other. That's how that works. How much is remaining? Count them. 1, 2, 3, 4, 5. That's all it is. So this is basically a review of adding integers with different signs. That's all it is, adding integers. Now, what happens if we have more negatives than positives? Let's try that one, okay? Let's put down 5 positive, and we just add on, let's see, how many negatives we have? We have 4 already. Let's take these off so that you don't get confused. Take these off here. Okay, let's put down 5. Let's put down 5, 6, 7, 8. Let's put down 10, okay? 10 negatives. Now, let's represent these as integers, okay? Represent these as integers. Let's erase this. I want you guys to get this now, all right? Let's erase this. Okay, now we have how many positive charges do we have here? Let's arrange these neatly here. 1, 2, that's 4, 5. Okay. So what do I have here? I want to put these very neatly. Okay. So I have a total of what? A total of 5, positive 5, plus how many negative tiles do I have here? Count them. That's a total of negative 10. Okay? So what's happening? I have more negative than positive because my answer is going to be positive or negative. It's going to be negative. Now, what's going to happen? Each one cancels out the other. Let's do that, please, okay? These two are gone. These two are gone. These two are gone. These two are gone. And finally, these two. How many is remaining? 5 positive or 5 negatives? The answer is negative 5. Any questions? Okay. Now, let's get to the example here, okay? Open your books. Let's look at example number 1 in your book. Please look at example number 1. Okay, let's put this to the side. Don't want to lose these. Please look at example number 1. Okay, example 1, we have x plus negative 2 equals to negative 7. Now, how do we represent that as algebra tiles? Okay, what color is our x, our positive x? It is green. Okay, remember, all red is negative. What color is our negative 1 or negative 2? We need 2 reds, right? So plus 2. Same thing in your book. And I need 7 red small squares, right? So we have 1, okay, 2, 3, 4, 5, 2 more, and we have 7, correct? Let's put them all neatly together. Okay, now watch how this works. Very simple. Okay, now we want to solve. This is what you call a one-step, we call it one-step subtraction equation. If I'm going to call it that way, one-step subtraction. Why? Because we must get rid of this negative 2 here. Okay? So what we want to do, let's write this down. We want to do, every time you solve an algebraic equation, or you want to get the solution is whatever we find x to be. So to find out what x to be, we must get rid of everything that's on the same side of the equation where the variable is. So we must, next time we must isolate the variable x. Now, how do we isolate x? We must get rid of these 2 here, right? So what can I add to a negative 2 and get 0? We must add positive 2. Let's do that. Add positive 2 here. And you know that positive 2 and a negative 2, these are going to cancel out each other, right? But look, in order to keep everything balanced, if I add a negative 2 on this side, I must do what? I'm sorry, if I add positive 2 on this side, I must add positive 2 on this side, right? Let's do that, please. Let's add positive 2 on both sides. Okay. Now, let's simplify both sides. Positive 2 plus 2 negative 2, they cancel out each other, right? Okay, therefore, these 2 positives are going to cancel out with 2 negatives on this side. Now, what have I done? I have isolated the x. I have x equals to what? Do I have what? 1, 2, 3, 4, 5 positive or 5 negatives? I have 5 negatives. So therefore, my solution is x equals to negative 5. Now, how would you solve this algebraically without algebra tiles? You probably already know how to do this. Let's write the equation over again, okay? Let's put this over here. Let's rewrite the equation. We have x plus a negative 2 equals to negative 7. The first thing we're going to do, what did I do up here with the algebra tiles? I added 2 positive to isolate the x. So if I add 2 positives to this side, okay, I must add 2 positives to this side. Why? In order to keep it balanced, right? So now, what's going to happen? A number and its opposite is 0. Bring down the x equals, now how much is a positive 7? I'm sorry, how much is a negative 7 plus a positive 2? Well, it's going to give us a positive 5. I'm sorry, a negative 5. Yes, negative 5. Okay? Any question about that? Now let's look at this over here, okay? Let's turn this off. We're going to set up the same problem with this. Okay. It's the same concept. The problem is x. Let's plot the x. It's the same thing. Now let's give you probably a better picture because this is like a balancer, right? Okay, so here we go. We have here, this is x. Now what is negative 2? That's a negative, we need red. So let's go to our red bag here. Okay, let's put out a negative 2. So, okay, so we have x plus negative 2 equals to a negative 7. So I gotta figure out where's the 7 here. On one of these, okay, equals to a negative 7. Okay, this is the same problem we had with the algebra tiles. Okay, this is hands-on math, right? Okay. Now, how do I isolate the variable x? Now remember, the solution is not negative 7. The solution is whatever x is alone, isolated. So we want to isolate the x. So now what? So I have x plus a negative 2. What must I do to isolate the x? What can I add the x? I must add, what's the opposite of negative 2? Positive 2. Let's do that. So we're going to add positive 2 to this side. If I add positive 2 to this side, I must add positive 2 to the other side. Here we go. Okay. Now what's going to happen? Wrong side here. Positive 2. Okay. Now, thank you, Melissa. Anyway, now, positive 2, negative 2, they cancel out, right? We can take these away. We've isolated the x. But now, we must simplify this side. How much is a positive 2 plus a negative 7? A positive 2 plus a negative 7 is a, I need a 5 here, is a positive 5. No, it's a negative 5. Okay? So look what I've done. I made it here. I have x equals to negative 5. Okay, so the solution to this equation is x equals to negative 5. Okay, very good. Okay, now let's go on to the next example here. I think you guys got the hang of this. This is pretty simple, right? Very, very simple. Okay. Let's go to the next example. The solution is negative 5. Go to the next page. Let's see. Here's the next problem. This right here. Next problem. Okay, let's turn this overhead on. Look at the next problem. How about example 2 in your book on page 117? We have example 2. We have x minus 3 equals to 5. Okay, now, how do we solve that problem? We must isolate the x, right? And of course, if you represent these with algebra tiles, the x is going to be green. So this is x plus a negative 3 equals to 5. Because you can change subtraction to addition, right? Okay, because what? Subtracting a number is the same as adding the opposite, remember that? Okay, so now I must add negative 3, so I need 3 small squares. 3 small squares, okay? Let's go ahead and make our square here. This is our equal sign. Equals to positive 5, so now I need 5 yellow. 5 yellow. 1, 2, 3, 4, 5. Okay. Now, what must I do? I must isolate the x. That means I must undo these negative 3's. What can I add to negative 3 and get 0? I can add positive 3, right? But if I add positive 3 to both one side, I must add positive 3 to the other side, right? Here we go. Okay, so I must add positive 3 to this side. I must add positive 3 to this side. So here we go. Before I put the positive 3, let's make sure it looks good here. Okay. So now I'm adding positive 3. Oh, that's a negative. Okay. So now I'm adding positive 3 to this side. Okay. So what's going to happen? These positive 3's are going to cancel out with these 3 negative 3's, right? So let's pull those out. And the positive 3 that we added to this side, because we added positive 3 to this side, now they're just going to make this side larger. So we had 5 plus 3 more. Now we have 8. So what's our solution? We've isolated the x. So now we have x equal to 8. Is that our solution? The answer is yes. The answer is 8. Okay, the answer was not 5. The answer is 8 because we found, let's check it, okay? Our equation, we have x minus 3 equals 5. Now replace the x with the solution 8 minus 3 equals 5. Is 8, subtract 3, is that 5? We have 5 equals 5. Balance. We're finished. Okay. Alright. Now, let's move on. I think you understand that pretty well, right? Okay. What I'd like for you to do is go to page 120, where it says check for understanding. I want you to move into your groups. Make sure that everybody, each person, I hope there's enough to go around, get one packet of these. If there's not enough to go around, share, okay? Identify your positive tiles and your negative tiles. Remember, all the reds are negative. You got that? Okay. Now, I want you to go do this. Turn to page 120. I want you to go to understanding now. I'm sorry, check for understanding. Check for understanding. This is on page 120. I want you to solve problems. This is just for quick practice with your algebra tiles. Solve problems 1 through, let's see here. Solve problems 1 through 14 all. Okay? So let's see. Since you're playing with the algebra tiles, I'm going to give you, let's say, 15 minutes. Okay? So, 15 minutes. Okay? Move to your groups. Take 15 minutes. And you can divide these problems up. Let's say, since there are 4 of you, between 1 and 14. Let's see. That's not quite 2 problems each. So 2 of you can take 2 problems. And some of you only have 1. You should be able to solve these 15 minutes. Okay? All right. We'll get started. Okay. We're back. How did you do, man? Okay, let's go over the answers, all right? I assigned problems 1 through 14 all. So here we go. Let's go problem number 1. Well, I'm just going to go over the answers because I think this is too easy. Okay, what's the answer for problem 1? It says show how to model 5 plus x equals to negative 2. Okay, that's very simple. 5 yellows, right? There we go. 5 yellows. Okay. 5, 1, 2. I need 3 more. Get them all at once. Here is 5. What is x? Is it red or green? It's going to be green. X is green because x is positive. 5 plus x equals a negative 2. There we go. Five plus 1 equals negative 2. You should have 5 yellow small squares, 1 green rectangle, plus 2 small red squares. And that's the answer. Very good. All right, go to number 2. Explain why the model below represents x minus a negative 8 plus negative 6. Well, the answer is subtracting a negative is the same as adding a positive. So therefore, what you have here, let's take this off. We have, what you have here is, let's erase this. Sorry for the delay here. Okay. And, okay, so what you have here, you have x minus a negative 8 equals to negative 6. You're subtracting here, so you can always change the subtraction problem to addition. So subtracting a negative is the same as what? Adding a positive 8. So, that's the reason why, and that's your answer. Okay, let's go to the next problem. Number
3.
Read the equation. Number 3. Write an equation for each model. Okay? What is the answer for number 3? Your answer should be, what's the answer? You should have x plus a negative 2 equals to 12. Very good. Let's go to number 4. Number 4, you should have negative 4 plus x equals to negative 3. Let's get a better sheet here. That looks pretty bad. That looks very, very bad. Okay. Okay, what's the next problem? Look at number 5. How's that look? That look better? Number 5, you should have 7 equals negative 6 plus x. Let's go to number 6. have x plus 9 equals negative 5. Let's slow down. Am I going too fast? Okay. Get everybody a little time to catch up here. Okay. Now, let's go to number 7. Let's read the instructions for problems 7 through 14. Solve each equation. Use algebra tiles if necessary. Okay. Let's go to m plus 2 equals to negative 2. Now, how do we solve that? Well, you must isolate the m, but you're adding 2. How do I undo adding 2? Or how can I add 2 positive 2 and get 0? Add negative 2. But if I add negative 2 to one side, I must add negative 2 to the other side. Simplify and give us m equals to, now how much is negative plus a negative? That's a negative 4. So the solution is m equal to negative 4. Very good. Let's go to number 8. And I'm not going to solve them all, I'm just going to give you the answers, okay? So problem number 8, you should have 9. Problem number 9, negative 4. Problem, you should have 2. Problem number 11, you should have 6. It is 6. Okay, problem number 13, you should have, the answer is 3.
Question number 12.
And I skipped 12, right? Number 12, the answer is 0. Thank you, Melissa.
And
Okay.
14.
And now let's go to number 14. Okay, let's go to number 14. Let's clear this off. Let's go to problem number 14. All right. Number 14. It says this is a sales problem application. Jeff Simon sold 27 cars last month. This is 36 fewer cars than he sold during the last time period 1 year ago. What were his sales a year ago? Okay. Okay, so now he sold 27 cars, so that'll be 27. But it says he sold 36 fewer cars. Isn't that minus 36? Okay. Then he sold the same time a year ago. So we're going to let x equal to what he sold a year ago. Now be careful now. When you're solving this word problem, the one thing that you always ask, you focus on this. Let's write this down. You want to focus what? What is the problem asking for? Always do that when you're solving a word problem. So, what does the problem ask for? It says, the very last sentence, what were his sales 1 year ago? So we let x equals to sales 1 year ago. So we go x. Now, it says he sold a total of 27 cars altogether. Okay, so it's going to be x equals to 27. But it says this is 36 fewer cars than he sold during the same period 1 year ago. So it's going to be minus 36. Okay. So how to find it? We're going to work with x minus 36 equals to 27. So we're trying to find out how much he sold a year ago. So what must I do? I must isolate the x. So what is being done to the x here? You are subtracting 36 from x. So now, how do I eliminate this 36? What can I add to 36 to get 0? The answer is positive 36. If I add 36 to the left side of the equation, I must add 36 to the right side of the equation. Why? Because it's like a balance. Add 36 to this side, right? It's going to tip down. Therefore, I must add 36 to this side and make a balance, okay? So, take negative 36 and a power 36, that gives us 0. Bring down the x. Now, how much is a positive 27? Plus 3 is 6. So what's my answer? The answer is 36. 6. Okay. Very good. Thank you, Melissa. Okay. So the answer is, I don't know why I said 36. Okay. So the answer is 36. So 36 is called 63 is called the solution. Not 27. 63. Let's check it. Here we go. Our problem was x minus 36 equals to 27. Solution. What do we get for our solution? Our solution is 63, not 36, I'm sorry. Okay? We're going to what? We're going to check our answer. How do we check it? We're going to plug it in. Okay? So we're going to go, in place of the x, we put parentheses, minus 36 equals to 27. Plug in 63. Now how much is 63 minus 36? Well, 6 from bar 1, 6 from 13 is 7, 3 from 5 is 2, and okay. Are there any questions? Now, I want you to do the rest of the class, take the rest of the class time. I want you to practice, and I want you to solve problems, your exercise problem. It's the same routine. First, I go over a few examples, then I do the check for understanding, okay? Then I give you comprehensive practice in class. So you've had 2 opportunities to practice in class today, all right? So before you walk out that door, you should know how to do your homework. You should go home and show anyone how to do your homework. Hopefully you shouldn't have to be paying any money for tutoring because you got your teacher here, right? Okay, so here we go. So this is for class practice or worksheet, okay? If no one passes out a worksheet for you, then do the class practice. So, class practice, I want you to solve. Class practice. This is textbook. Solve problems. Odd problems. 15 through, let's see here. Let's solve problems 15 through 33 R. And that's on page. That is on page 121. Okay, so that should take the remainder of the class. Take time to practice. You may work in groups. So now, when I go off the tape here, go right ahead, move back into your groups, practice each and every problem, and make sure. Don't forget to do your homework. Okay? Look at your homework on your homework calendar. And the homework problem. This is lesson. We're on lesson 3-5. And 3-5 this Monday, I'm sorry. You're going to solve problems. You're going to solve problems 20 through 38 even. I always assign the even problem because the answer's not back in the book. And page is what? Just one page, page 121. Okay, so now you should have enough arsenals to do your homework. No excuses. And I hope that by the time I get back, you guys are making straight A's and B's, okay? Okay, go right ahead, move to your groups. Practice, practice, practice. Get them all correct, and I'll see you later, all right? Thank you very much.